I'm the Chief Propulsion Engineer at Dynetics, and we're here looking at propulsion today. And these are rocket engines we developed in the last year, and these are hydrogen peroxide. They run 90% concentration, same kind of peroxide you got at home, but very highly concentrated. And they use a catalyst to actually convert the peroxide to hot steam, about 1200 degrees F steam. So these are medium performance engines, but their propellants are very storable, and they've been around for a long time. They flew X-15, RCS, the reaction control systems with these propellants. They also flew the Mercury, and their Russians have used it quite a bit. So what we're doing with these are we've been supporting the lander work with NASA Marshall Space Flight Center. So what they're doing is we developed a lander and the propulsion system for this guidance. Had over 150 flights, and it's to test the guidance and control systems and the sensors for what ultimately will go to the moon and be precursors for some of the manned moon missions. In fact, ILN is about International Lunar Lander Network, and they're going to go on the moon and measure seismic activity and things and try to understand what's going on within the moon. And this is so we've learned a lot about how to fly and land and touch and goes and do things like that with that. And now we're building a peroxide system that we just finished, and it uses these thrusters. They were developed to fly this for up to 45 seconds, maybe up to a minute of flight time, is where this could only fly for 10 seconds. So now we're going for longer flight. So we had Teledyne Brown did the structures, and we did all the propulsion at Dynetics, and we did all our own testing. We've got a facility not far, right outside of Huntsville. We do all the testing. You're looking right here at a Bigelow system. Bigelow Aerospace, is doing an on-orbit space station. They have 2 unmanned versions right now, and these are thrusters to do maneuvering on orbit. What's unique about them are the fact that they run on hydrogen and oxygen that is generated from living and working there. For instance, the wastewater byproducts, we actually take those byproducts and we crack the hydrogen and oxygen from dirty water, sweat, urine, and we burn it. So we're not having to carry any propellants with us. Human beings will carry propellants, and by virtue of living there, we're basically recycling in space. So that's a pretty cool product. These produce 5 pounds of thrust each. There's a total of 8 of these on each Sundancer module, and hopefully they'll launch here in the next couple of years. So we developed other products to try to save mass or weight. Okay, what you've got here is something that looks a lot like a taser, and it is high voltage, but what it is a very lightweight solution to something that we've done the same way for many years. This thing weighs about a pound, but it's replacing something that, if you look in here, these boxes here, they weigh about 3 pounds a piece, and they do the same function. And we decided that it'd be great, since we have 8 of those engines, if we could save 16 pounds of mass or so by going to our own system and get rid of the high voltage wires, which are like transmitters, and they emit RF and create all kind of havoc for electronics. We wanted to do that. So we took this on as a project and highly integrated a high voltage system into this little package, and that's a spark plug, by the way. It's a $1,200 spark plug, but it is a spark plug, but the whole purpose was to save mass and get rid of noise. So that was a product we've done, and this actually has lit a lot of rocket engines at the NASA facilities, and we're starting to work with big primes to make this part of their engine programs, and so it ultimately will be flying. So anyway, this is just a few examples of some stuff we're working. We built a large engine here. This is a very heavy boiler plate, but we actually built some of these that were very lightweight. And this is actually a valve right here for the two propellants. In this case, it's nitrous oxide and ethane. And those are storable, non-cryogenic propellants. We're running them at about 0 degrees F. So the density is pretty good for nitrous. And this is actually embedded in a big tank, which is the launch vehicle. And so you don't see the rocket engine, but it's the reason we did that is it helps precondition it to the temperatures that you're going to run it at, so you don't have to do all this cycling and purging prior to launch. And also we did that in order to inject nitrous for steering the vehicle, so you don't have any gimbaling engines and things like that. So it's a very low cost rocket solution. And we were targeting to be able to get a 25 pounds to LEO for $1 million, by the way, dedicated. You give me your payload, and 24 hours later we have you on orbit, a small sat or microsat. So anyways, so this is the serious side of what I do at Dynetics, and a more fun project, but just as serious is the Rocket City Space Pioneers project, where our team is going back to the moon, and we're trying to compete with 29 teams internationally, so we can win that prize and create a new business model for
speaking about
the Google Lunar X Prize. That's correct. And for us, yes, we want to win the prize, but more importantly, we want to generate a paradigm shift in cost. And we think we can do that through doing a rideshare program. So let's go over and take a look at some cool Google X Prize stuff.